Welcome to lecture number 36. In this lecture, we will discuss the last chapter of transmission and distribution, which is distribution system. So the distribution system is not so important for gate. So mainly few calculations we need to do here. So one is distributor fed at one end, distributor fed at both ends. Okay, these are the only two things we are going to see here. Anyway, so what is really distribution system? If you think about our Indian power system, from 33 kV and below, that is called what? Distribution system, and 66 kV and above, which is called what? Transmission system. If you see practically, the highest transmission voltage in India is 765 kV. The 765 kV is the highest transmission voltage in India as of now. If you go down 400 kV, then 220 kV, then 132 kV and 110 kV also there, and 66 kV very rarely used. Then after that the distribution system will start, which is 33 kV, 11 kV and 415 volts, and finally 230 volts. Now these are the standard voltages as per our Indian power system. Okay, clear? So this is what transmission system, and this is what we say distribution system. Okay, but if you really notice the complete transmission system now, this is what transmission system. Yeah, the complete transmission system is what? 3-phase 3-wire supply. You will not find any 4th wire. Basically it is a 3-phase 3-wire supply. Now coming to distribution system. The distribution system means, again I am dividing the distribution system into two parts. Now this is what? Primary distribution, which is basically 3-phase 4-wire supply. Sorry, 3-phase 3-wire supply. Primary distribution is 3-phase 3-wire supply. But 415 volts and 230 volts, these two are comes under secondary distribution. Secondary distribution. Clear? It's a secondary distribution. Now complete together we say it is what? Distribution system. This is what our distribution system. But if you really notice, 415 volts is what? 3-phase 4-wire supply. Clear? 3-phase 4-wire supply. Sometimes we use 5th wire also. That 5th wire is dedicated for what? Maybe street lighting. Okay, but basically if anybody asks is it 4-wire or 5-wire, means 4-wire only, standard is. Okay, sometimes depending on the requirement a 5th wire will be dedicated. A 5th wire means it may be connected to R phase, or may be connected to Y phase, or may be connected to what? Directly B phase, but through which what? All the street lights get what? Supplied. Okay, so in that case we say it's a 3-phase 5-wire. Okay, but standard is 3-phase 4-wire. Right? Now 230 volts means it is a single phase what? 2-wire supply. Single phase 2-wire supply. That means R phase wire, maybe Y phase wire, or maybe B phase wire, whatever it may be. One of R or Y or B phase wire is taken, and what? Neutral wire is taken, through which what? Single phase consumers are connected. So that's about 230 volts. It is a single phase 2-wire supply. Okay, now again I am saying 33 kV and below distribution system, and 66 kV and above, which is what? Transmission system. The complete transmission is 3-phase 3-wire, and complete primary distribution also 3-phase 3-wire. But when it comes to the secondary distribution, means 3-phase 4-wire is there, single phase 2-wire is there. Now if you think about our Indian power system, sir, let's say there is a 132 kV by 33 kV substation. So this substation is under the control of what? Transmission authorities. Clear? That means the maintenance, erection, and what if any problems are happened, the rectification of that problems, everything is done by what transmission companies here. Okay, now let's see, this is what 33 kV bus. Before this we have a transformer, that is 132 kV by 33 kV transformer. That means what my point is, from here so many 33 kV lines are going out, correct or not? Now this is what 33 kV line. Okay, now all this 33 kV lines comes under what distribution system. Simply speaking, the distribution companies must be taken care of these 33 kV lines. Okay, now if you take one particular 33 kV line which is terminating at a 33 kV by 11 kV substation, 11 kV substation. Okay, so here we have a transformer indirectly which is stepping down from 33 kV to what 11 kV, correct or not? Now from here what lot of 11 kV lines are going out. Okay, so these are all what 11 kV lines. Now if you see one particular 11 kV line to which what so many DTRs are connected, clear, something like this. Now these are what DTRs. DTR means what distribution transformers. It's not just one or two or three, that depends on what requirement. So many DTRs are connected. Now this is basically a what 11 kV transmission line. Okay, sorry, 11 kV distribution line. Now let's see, after the DTR the supply is what highly radial in nature. Okay, clear? So your house is connected here through a what a service main, clear sir, which is basically 415 volts. Before DTR it is what 11 kV. So your house is connected between line to what neutral, clear sir. In modern system maybe your house is getting what directly 3-phase supply. Okay, clear, it might be 3-phase supply is given or what single phase supply is given depending on what requirement. Anyway, now let's see here. This is, if you start from your house is what 230 volts which is connected between what line to neutral, and before that what 3-phase 4-wire supply which is what basically at 450 volts, and if you go further 11 kV, then what 33 kV, then what 132 kV, something like that. Okay, but as I told you already, this is comes under what our distribution system, and before this which comes under what transmission system. Clear? Now there are 3 important definitions which we generally come across in distribution system. Number 1, service main. See, this is what we call service main. Number 2, distributor. This is very, very important in distribution system. So many consumers are connected to what? Distributor. Clear? So we say it is a distributor. That means this 415 volts is line called what? Distributor. Now this 11 kV line is there now that is called what? Basically a feeder. Clear? Now we need to define feeder, distributor and what? Service main. Clear? So service main means what? It is the connection point from the consumer terminal to what? Distributor. Clear? That means the consumers are connected to the supply system through a wire, and that is called what? Service main. That means every consumer is connected to what? Distributor through a wire, that is called what? Simply a service main. So, but how you decide the size of the service main? The size of the service main is decided based on the connected load of the consumer. How much is the connected load? Based on that what? The size of the service main is decided. Okay? Clear? Because if connected load increases, then definitely what? You need to carry what? More current. That means the service main has to carry more current. So that means what? The size of the service main also what? Increases. Clear? Now, the next one is what? Distributor. Distributor means it is a line or conductor to which various consumers of distribution system are connected through their respective service main. It is a line or conductor to which various consumers of distribution system is connected to their what? Respective service main. Now that is called what? Simply a distributor. But while designing the distributor, the main focus is not the power, not the current, it is the voltage drop. Because all the consumers are connected to this distributor, then what? The end consumer should get what? Proper voltage. So that means strictly speaking, as per the standard, since you are promising to the end consumer saying that 230 volts, at least you should maintain what? Plus or minus 10 percentage. Forget about plus 10 percentage, minus 10 percentage. That means at least you should give what? 210 volt supply to what? The end consumer. That means the end consumer, that means starting from what? DTR to end consumer, we calculate the voltage drop. Now that voltage drop must be within what? Plus or minus 10 percentage. Strictly speaking, that should be what? So less than what? 23 volts approximately. Okay. So that means the voltage drop is the main criteria for calculation of size of the distributor. Suppose if voltage drop increases, what we do generally? We increase the what? Size of the distributor. If I increase the size, then naturally what? The distributor resistance will decrease. If resistance decreases, voltage drop also what? Decreases. That's why the size of the distributor is decided based on voltage drop. Clear? Now next one is the feeder. A feeder means what? It is a line or conductor which connects the major substation with what? DTR or distributor. A line or conductor which connects the major substation and what? Distributor. Now that is called what? Simply a feeder. But when you are calculating the size of the feeder, the current carrying capacity is the main criteria. That means the size of the feeder is selected based on what? Current carrying capacity. Clear? Because the consumers are not connected to what? Feeder. Correct or not? So after the feeder we have a DTR. You can play with the what? Turns ratio of this DTR, so that you can able to what? Maintain the voltage here 450 volts. That is a line voltage. And phase voltage is what? 230 volts. Clear, sir? That means if there is a voltage drop in the feeder is little high also, you don't need to worry. We can play with the what? This transformer taps, strictly speaking, so that we can able to maintain the 415 volts here. That means the voltage drop is not the main criteria here. Okay? The main criteria is how much will be the current. If current increases, yes, I have to increase the what? Size of the feeder. Okay? Now finally, the size of the feeder is calculated based on current carrying capacity. Size of the distributor is calculated based on what? Voltage drop. And size of the service main is calculated based on connected load. Now we will see types of distribution system. Basically two types of distribution systems, sir. One is a radial distribution system, other one is ring main distribution system. Okay? Radial distribution system means, let's see the supply is at one point. Now this is the supply location. Let's see the consumers are connected like this. So this is how the radial distribution system. Clear? Just for example, let's say this is 1 ampere current. Let's say it's a DC distribution system. It might be DC, it might be what? AC. But now we are using what? AC or DC? Yes, it is what? Completely AC system. Okay? Clear? Now let's say this is 1 ampere. 1 ampere, I am just considering what? DC system, just for what? Getting more clarity. So let's say 1 ohm and what? 1 ohm is the resistance of what? Each section, for example. Now think about what is the current flowing here? 1 ampere. What is the current flowing here? 2 ampere. What is the current flowing here? 3 ampere. Why? Simple. KCL. 1 ampere. Here what? 1 plus 1, 2. Here 1 plus 2, 3 ampere. So you think about here voltage drop is what? 3 volts. Here the voltage drop is what? 2 volts. Here the voltage drop is what? 1 volt. Correct or not? That means what is the total voltage drop? Which is what? 3 plus 2 plus 1. That means 6 volts. If you see from the source, the end consumer, till end consumer, we are getting how much voltage drop? 6 volts. From the source to end consumer, the 6 volt is the voltage drop. Now see the total power loss. The total power loss, before that the total voltage drop is 6 volts, and the total power loss is what now? Let's calculate here. 9 watts, 3 square into 1 ohm, plus 2 square into 1, 4, plus 1 square into 1, 1. So that means total 14 watts is the what? Power loss. Okay? So power loss is 14 watts and voltage drop is what? 6 volts with what? 3 consumers. Okay? Now this is about the radial distribution system example, sir. Radial distribution system. Suppose if it is a ring main distribution system, how it will be, sir? Ring main distribution system. See, the ring main means the same supply, na? Supply is same. Have a look how it is connected. There is a 1 ohm resistance, just for understanding. This is what 1 ampere, the first consumer, 1 ampere current is drawing. Now, this is also 1 ampere, second consumer, 1 ampere current. And what is the resistance of this wire? 1 ohm. And third consumer, let's say somewhere here, he is also drawing what? 1 ampere. Now, this resistance also what? 1 ohm. Now, this is what we say ring main. One more extra wire is added, so that what? It is just forming a ring. That means supply is from what? Both sides. Okay. So this is what now? 1 ohm. Now, what is the advantages of this ring main? If you notice, mainly the first advantage is, major advantage I am saying here, sir, for example, if there is a problem in this wire, I mean to say if there is a problem in this distribution section, so this distribution section is what? Disconnected. Problem means maybe there is a fault. What happens? This consumer will what? Experience a loss of supply. Okay, fine. Suppose if there is a fault here, then what? Again a breaker here, that will be open, breaker or fuse, whatever it may be, it is open. Then what? These two consumers experience loss of supply. Fine. Suppose if there is a problem in this section, then what? All the consumers who are connected to this distribution supply is experience a loss of supply. Correct or not? So that means the reliability is very less in case of what? Radial distribution system. Suppose if there is a fault anywhere, any one of the line you take it, for example, if there is a fault here, then what? There is a fuse or breaker here and there is a fuse or breaker here. These two will be open. That's how the protection is designed. We will see how to protect this ring main distribution system when we come across protection system. There we see directional relays. Okay, with the help of directional relays we can protect the ring main distribution system. Okay, we will see that point clearly there. But for time being, sir, both the side of the lines we require what? Relays and breakers. So in both side of the line we have a breakers and relay arrangement. That's why what? If there is a fault now, then that particular line only isolated without disturbing the rest of the network. Now let's see if there is a fault here. This line is isolated, but supply is there from here to here, supply is there from here to here. That means any consumer is get affected? No. That means what? The first important thing, the reliability is what? Very high here, but reliability is what? Very poor here. Okay, less reliability, and here what? High reliability. Okay, that is a first advantages of what? A ring main distribution system compared to what? Radial distribution system. Okay, now second thing is, if you notice, second comparison, sir, here the cost is very less, but here the cost is what? Very high. Why the cost is very high? Just now I said, a line both the side we have a relays and breakers, but here what? The relay and breaker is located here. That's enough. If there is a fault, this is disconnected. So only one side of the line having what? Relay and breaker arrangement, but here what? Both the side of the line having what? Relay and breaker arrangement. Okay, that means we require more number of relays, more number of breakers, more number of CTs, PTs. Okay, and also what? We need an extra line here. So that's why the cost of the ring main distribution system is high when compared to the what? Cost of radial distribution system. Okay, that is about the second comparison. Now third comparison is, sir, radial distribution system is very, very simple, but it is what? A complex network. Okay, clear? It is definitely a complex one when it comes to the calculation point of view, when it comes to the protection point of view, when it comes to the settings of relays point of view. Okay, it is what? A complex in nature, but it is what? Very simple in nature. Okay, so that means simply radial distribution system is simple network, but ring main distribution system is a complex network. Okay, clear? Now fourth comparison, sir, have a look, sir. Here we calculated the voltage drop as 6 volt. That means from supply to what? End consumer. Okay, but here what? This is the supply and you can say this is the end consumer. Okay, clear? That means we need to see what is the maximum voltage drop here. Let's see, the current here is 1 ampere now. This side 1 ohm, 1 ohm, and here tapping is 1 ampere, tapping is 1 ampere. It's a symmetrical both the sides. That's why what? So even you can do the calculations. So we get here what? 0.5 amperes, and here also what? 0.5 amperes. Okay, if that is the case, what is the voltage drop in this section? 0.5 volts. Now let's see, 0.5 ampere is tapping from here, then 1 ampere is going here. That means what is the current here? If you apply KCL, 1 and 0.5 is going out, then we get 1.5 watt ampere here. Okay, now let's see here, here also 1.5 ampere. So what you can understand here, this is 1.5 volts, and what about this? 1.5 volts. Look here, sir, 1.5, 0.5, 2 volts. Here also 1.5, 0.5, 2 volts. What is the meaning, sir? Indirectly this is what? End consumer. It's not an end consumer here, correct or not? Okay, so what is the voltage drop from here to here? 2 volts. What is the voltage drop from here to here? 2 volts. That means what is the maximum voltage drop here? 2 volts. That's it. But here, sir, what is the voltage drop? 6 volt. That means in case of ring main distribution system, voltage drop in the distributor is less, but here voltage drop is what? More. Okay. Now similarly, what is the power loss here? Just see here, 1.5 square into what? 1. Power loss, I am just calculating, 1.5 square into what? 1 plus 0.5 square into what? 1 plus 0.5 square into what? 1 plus 1.5 square into what? 1. So this is what the power loss here. If I solve this, we get 5 watts. But check here, how much is the power loss? Total power loss 14 watts. But here what? 5 watts. What you can understand from here, sir, in case of ring main distribution system, definitely power loss is less, but radial distribution system power loss is more. Okay, clear? But tell me, our Indian distribution system is ring main or radial? Sir, it is a radial distribution system. The reason is what? Ring main require more cost, radial require what? Less cost, correct or not? So that's why, so cost point of view, we are going for what? Radial distribution system. But where we use this ring main distribution system? Inside the industry. For example, there is an industry. So after the power is, after the line maybe at 33 kV or 132 kV is supplied to what? Industry, then inside the industry they will form a local distribution network. Now that local distribution network is what? Generally ring main. Okay, their cost is not the criteria, reliability is the main criteria. But think about our domestic consumers. In your house, reliability is the main criteria? No, the cost is the main criteria, correct or not? If there is a loss of supply for half an hour or 1 hour, nothing will happen. It's not a great impact. Okay, we may feel discomfort, but it's not a great impact to the system point of view. Okay, if you want to provide a ring main distribution system to what? Every consumer, no? The cost become what? Very high. That means the cost will be increases dangerously. That's why, so our Indian distribution system, if you see, our consumer distribution system, if you see, that is basically what? Radial one. Okay, but in the industries, they will form a local distribution system. There the people may use what? Ring main distribution system. The next thing is types of distributors. Sir, if there is a question from distribution system, means generally we get a numerical question from what? Types of distributors. Okay, basically there are 2 types of distributors, sir. Number 1, distributor fed at one end. Distributor fed at one end. Number 2, distributor fed at both end. Distributor fed at one end, distributor fed at what? Both the end. Okay, in both the cases the loading may be concentrated loading second case uniform loading. Similarly here also concentrated loading and what? Uniform loading. Okay, it might be concentrated loading, uniform loading. Till now the question is not given in GATE exam on uniform loading. The question will be generally given on what? Concentrated loading. And distributor fed end both ends is what? Very important. Okay, because distributor fed at one end is what? Very simple, KCL and KVL, nothing else there. Okay, but if there is a trick, means the trick is there in what? Distributor fed at both the ends. Anyway, we will see distributor fed at one end, both the end, with two cases, concentrated loading and what? Uniform loading. First we will see distributor fed at one end with concentrated loading. So distributor is fed at one end. Fed at one end means what? Supply is from only one side. Now this is the starting point of the supply. Okay. So let's say this is what the point number A. So that means VA is nothing but what? Supply voltage here. Right. Now let's see, at this point consumer 1 is connected. Then after that what? Distributor is going, and what? Consumer 2. Then consumer 3. Something like that. Okay. I am just showing 3 consumer to get what? Simple understanding. Right. Sir, in case of this distribution system, the consumers are shown with how much current they are drawing. Okay. If it is a DC means what? Only magnitude of the current. If it is an AC means what? Magnitude of the current with power factor is given. Otherwise phase angle is given. But that phase angle is by default with respect to what? Supply voltage. For example, let's say this is 1 ampere at an angle minus 30 degrees. This minus 30 degrees from supply voltage by default. Means voltage is our reference. V at an angle 0. Suppose if it is a 230 volts, means 230 at an angle 0 degrees. Here 1 at an angle what? Minus 30 degrees amperes. Okay. Otherwise what he will mention? He will mention the current magnitude 1 ampere, and he will give you that the power factor is what? Let's say 0.6 lag. You can calculate power factor angle, that is here 53.13. So 1 at an angle minus 53.13. That minus 53.13 from where? From the supply voltage. Okay. Clear? If that is AC means. DC means no need to worry. Simply what? Magnitude of the current, because there is no phase angle, right? Okay. So here also magnitude of the voltage. Let's say it is 230 volts, something like that. Now let's say the current here I2, current here I3. Okay. That means I1, I2, I3 values are given. Clear, sir? Sometimes in the problem the total length of this distributor is given. Total length is given here, and he will give you the what? Length of what? Each section. So that means section AB, section BC, section what? CD. Every section length will be given. For example, length equal to, let's say, 1 kilometer, just for understanding. He will say that this is 500 meters, this is 200 meters, and this is what? 300 meters, something like that. Length will be given. Okay. And he will say that the total length of the line, the resistance or the total resistance of the distributor may be given, let's say 10 ohms. If that is the case, 10 ohms for 1 kilometers. Now tell me 500 meters means what? Half. Means what here? 5 ohms. Simple. Now 200 meters means what? Here 2 ohms. Then 300 meters means what? Here 3 ohms. That means every section resistance we can calculate. Otherwise sometimes in the problem directly what? Resistance is given. Otherwise if resistance is not given, something like this, length is given. Okay. And he will give you the what? Total resistance of each section. Otherwise resistance per what? Per meter length also given. Something like that. That means the first step what you need to do is you must identify the current and you need to calculate what is the resistance of each section. Some hint will be given to calculate the resistance of each section. Otherwise directly he will give the resistance of what? Every section. And later our calculations will start. Okay. But what kind of questions we can expect from this kind of problem means, sir, he will ask you what is the total voltage drop. Otherwise, what is the total power loss. Otherwise, let's say supply voltage is 230 volts. What is the voltage at point B, point C or point D? Sir, any kind of question you can calculate here using simple KCL and what? KVL. Okay. And Ohm's law. Nothing else here. Just have a look, sir. So, okay, I know the resistance of what? Every section. Let's say the resistance of section 1 is R1, section 2 is R2, section 3 is what? R3. Okay. So, once you are able to calculate the resistance, the next step is what? Current. What is this current, sir? I3. This current, I mean it is a section CD current is what? Whatever the current drawn at what? Point D. Then what is this current? I2 plus I3. Correct or not? Simple KCL, nothing else here. What about here? I1 plus I2 plus what? I3. Okay. Now tell me what is the voltage drop in section AB? Delta VAB, voltage drop in section AB. Delta V indicates voltage drop. What section? AB section. How to write? Simple, Ohm's law. Current multiplied with resistance. Suppose if it is an AC system, you will get what? Magnitude and phase angle, magnitude and phase angle, magnitude and phase angle. Just add them. Correct or not? And resistance will not be given there. Their impedance will be given. R plus JX. Okay, that means we need to do with what? Complex number here. We need to deal with the complex number in AC system. DC system is we deal with what? Real numbers. Okay, clear? So, but generally he will not give you AC system problem, he will give you DC system problem. The reason is what? So, you need a calculator which is what? Comfortable with what? Complex analysis. Okay, clear sir? But in GATE exam, whatever the calculator is there, that you can, there you cannot what? Directly add the complex number and multiply the complex number. Okay, we can do the calculations, but it takes what? More time. That's why generally he will give you what? DC system. Even if it is given AC system, you can easily calculate sir. Okay, nothing great. Anyway, delta VAB, what I can write now? R1 times I1 plus I2 plus what? I3. Now tell me, what about delta VBC? That means voltage drop in section BC. Simple, R2 times I2 plus I3. And what about delta VCD? R3 times I3. Okay, now tell me what is the total voltage drop? Total voltage drop equal to delta VAB, then delta VBC, then delta VCD. Clear? Now I can calculate what? Voltage at section B or voltage at point B. Voltage at point B is what? V minus delta VAB. Voltage at point C, V minus delta VAB plus what? Delta VBC. Correct or not? And you can calculate the voltage at this point also. That means you can calculate the voltage at any point in the distributor. At any point on the distributor using what? Simple KVL. Okay. Now what is the power loss? The power loss equal to simply total power loss. Sir, the power loss in this section is what? I square into R1. Correct or not? What is I here? I1 plus I2 plus I3. I1 plus I2 plus I3 whole square into R1 plus next I2 plus I3 whole square into what? R2 plus here I3 square into what? R3. So that's how we can calculate what? The total power loss. Clear? So we will take an example so that we can get more clarity on these calculations. Let's see this question which is on distributor fed at one end. See, it's a DC distribution system. You can easily understand why the magnitude of the currents only given, phase angles are not given. 10 ampere, 20 ampere, 10 ampere is given. These are what? The loads. Load 1 is drawing 10 ampere, load 2 is drawing 20 ampere and load 3 is drawing 10 ampere. Now first question is calculate the total voltage drop. So you need to calculate total voltage drop in all the sections. Then calculate what? Supply voltage. If point C voltage is 200, then calculate the total power loss. Let's see first. Sir, what is the current here? There is no any other consumer after point D. That's why current here is 10 ampere. Now you calculate the current here, which is what? 30 ampere. Now you calculate the current here, 30 plus 10, which is what? 40 ampere. Clear? Now check what is the voltage drop here. 40 into 0.1, 4 volts. Voltage drop 30 into 0.1, 3 volts. And voltage drop here 10 into 0.2, 2 volts. Clear? Now what is the total voltage drop? You just add them, 4 plus 3 plus 2. Nothing but what? 4 plus 3 plus 2, 9 volts. That's it. The total voltage drop is 9 volts. Now let's see second question. If point C voltage is 200 volts, then calculate the supply voltage. That means it's clearly mentioned that here the voltage is what? 200. Then what is the supply voltage? Simple sir. So what is the voltage drop here? 3. That means this side plus, this side minus. And supply load voltage is what here? 200 volts here. Okay, plus minus. And here plus minus what? 4 volts. Here plus minus what? 3 volts. Because current entering terminal is what? Positive. That's it. Simple. Now what is the voltage here? You just apply the KVL in this loop. Simply 200 plus 3 plus 4. Clear? If 200 volts is here means here 203. Here what? 203 plus 4. Total what? 207. That's it. 207 volts. Okay. Next, calculate the total power loss. So what is the total power loss? Here 40 square, current square into resistance 0.1 plus here 30 square into 0.1. Then next 10 square into 0.2. If I solve this, we get 270 watts. That is a total power loss in the distributor. Clear? Now this is how we can deal with distributor fed at one end. Nothing here, sir. Simple KCL and KVL. Now we will see distributor fed at both ends with concentrated loading. Okay? Both ends means what? This is one end. Let's say here the voltage is V1 and the loads are connected like this. And then here also what? The supply is there. This is V1 and what about this? V2. Okay? Supply is from what? Both the side here. Right? So V1 may be equal to V2 or V1 may be what? Different from V2. Okay? Now let's say this is I1, I2 and what? I3. These are the concentrated loads. Loads are here concentrated. Now the resistance of every section, you know, R1, R2, R3 and R4. Sir, here we need to calculate the voltage drop. But here we need to calculate the maximum voltage drop, not the total voltage drop. Total voltage drop means what? Direct answer, V1 minus V2. Correct or not? We will prove that V1 minus V2 is the total voltage drop. But that is not going to give any meaning. Okay, because you remember we discussed the distributor size is designed based on the voltage drop, but not the total voltage drop, maximum voltage drop. Okay, that means where we are getting the minimum voltage, that is really a question here. Okay, clear, sir? That means, so the minimum voltage along the distributor should be within the limits. Okay, within the limits means what? Plus or minus 10% limits. Correct or not? So anyway, let's see how to go for calculations here. Very simple, sir. I cannot say this current is I1. I cannot say this current is I3. So that's why what the point is here, assume from here or from here, it's up to you. Assume the current is what? Ix. Okay. I am assuming that this current is what? Ix. Okay. Ix may be negative or may be positive. That depends on what? The final answer. Okay. So that's why finally what we redistribute the current based on the Ix value we got. But we proceed like this now. Ix. Then what? This current is Ix minus I1. And this current is what? Ix minus I1 minus I2. Correct or not? Ix is coming, I1 is going, so Ix minus I1. Here Ix minus I1 is coming, I2 is going, that's why Ix minus I1 minus I2. And what about here? Ix minus I1 minus I2 minus I3. Clear? Now let's see what is the voltage drop. All the currents are in this direction. Na? That means the voltage drop here is plus minus, plus minus, plus minus and what? Plus minus. You just what? Add what? All the voltage drops. That is the total voltage drop. So the total voltage drop we can write V1 minus V2. Total voltage drop is what? V1 minus V2. Okay. Now how to calculate that? V1 minus V2, na? Simple KVL. So Ix into R1 plus Ix minus I1 into what? R2 plus Ix minus I1 minus I2 into R3 plus Ix minus I1 minus I2 minus I3 into what? R4. Clear, sir? Sir, I1, I2, I3 values you know. V1 and V2 also you know. What is unknown is what? Ix. Sir, let's calculate Ix. After calculating the Ix, you have to redistribute the current. After calculating that, you can calculate where the minimum voltage is coming and what is the maximum voltage drop, etc., etc. For example, sir, let's see. Let's assume that we got Ix equal to 35 ampere. Just imagine. Okay. Assume that what? For a given given values of V1 and V2, I substituted here and I calculated. Assume that I got Ix equal to 35 ampere. Anyway, V1, V2 are not given. If it is given means we can directly solve. But I am just assuming, sir, to get what? More clarity on this question. So, if Ix is 35 ampere, let's see. What is the current here? 25 ampere. If that is the case, what is the current here? 5 ampere. If this is 5 ampere, have a look. Check, sir. This is 5 ampere. But what is this current? 10 ampere. That means to satisfy 10 ampere, there should be a current which should come from here. Now let's see here, where the current is coming from both the side, there the voltage is minimum. Because we know that current is always flowing from what? High potential to what? Low potential. Since it is a low potential point, that's why current is coming up to here. And current also coming from here to what? Here. Because supply is from both sides. So that means only simple trick. Where the current is coming from what? Both the side to that node. That means at that node, the voltage is what? Minimum. That means, where is the voltage minimum, sir? I can say at point C, there exists minimum voltage along the distributor. So the minimum voltage point is what? Point C. Clear, sir? Now let's see what are the calculations we need to perform generally here. Let's see, this is what? 35 ampere now. So what is the voltage drop? This side plus and this side minus 3.5. Now this side plus and this side minus 25 into 0.2, 5 volts. Now this side plus and this side minus 5 into 0.1, 0.5 volts. Okay, but what about the voltage drop here? Current entering terminal is what? Plus. That means this side plus and this side minus. Okay, how much it is? 1 volt. Now let's see, sir. This is what our dividing section. Now tell me how much will be the total voltage drop here? Plus 3.5 plus 5 and what? 0.5. So total is what now? 9 volts here. From here to here is the 9 volts. But this side is what now? 1 volt. Now tell me, simple question, sir. If you want to design this distributor, what is our reference? I told you distributor is designed based on voltage drop. Based on 9 volts you design or 1 volt you design? Yes, 9 volts. Correct or not? That's why generally in the question he will not ask you total voltage drop. He will ask you what is the maximum voltage drop. The maximum voltage drop is not 5 volt. Maximum voltage drop meaning is what? From here to here the total voltage drop is what? 9 volts. The maximum voltage drop meaning is that. Okay, 9 volts. That means we can write what? Two sides. In the two sides which is maximum, that is called what? Maximum voltage drop. That is what here? 9 volts. Okay. Now what is the total voltage drop? 9 minus 1. That's it. Why? So this side plus and this side minus. But when you come from here, this side plus and this side minus. So that's why total voltage drop is what? 9 minus 1, 8 volts. Okay. Now you can calculate the total loss. Total loss means don't think that what? This minus this. No. Because current may be what? Reverse. But loss will be always positive because I square R. Correct or not? Here the loss is what? 35 square is into 0.1. Here 25 square into what? 0.2. Here 5 square into 0.1. Here 5 square into what? 0.2. Now that will be the what? Total loss. So we will solve a question so that you will get more clarity on this distributor fed at both the ends. But again I am saying, sir, here we are going to calculate what is the maximum voltage drop and what is the total power loss and where the minimum voltage is happening along the distributor. These are the three things we are going to calculate. Let's see this example on distributor fed at both ends. Sir, the distributor is given with the resistance of every section and what? Load drawn currents also given. Identify the minimum voltage location if V1 minus V2 is 3 volts. That is the first question. Second question is what? Calculate the maximum voltage drop. Calculate V1, V2. If minimum voltage along the distributor is 220 volts. Once I know the minimum location, I can fix that voltage to 220. From there I can calculate back what is V1 and V2. And calculate the total power loss. Okay. Now these are the questions we need to answer. Right, sir? Now let's see here. I can assume this current is what here? Ix. First we need to calculate Ix, then only we can identify the minimum voltage location. If this is Ix, what is this current? Ix minus 30. Then what about this current? Ix minus 30 minus 20. That means Ix minus 50. Now tell me what is this current? Ix minus 70. Okay. Now let's see. The V1 minus V2 is given 3 volts. Okay. So V1 minus V2 equal to 3 volts, right? V1 minus V2 equal to 3 volts, that is equal to 0.2 into Ix, 0.2 into Ix plus Ix minus 30 times what? 0.1. I'm just adding the voltage drops, okay? Plus Ix minus 50 times 0.3 plus Ix minus 70 times 0.1, okay? Clear? Now 3 equal to 0.2 Ix, 0.1 Ix, 0.3 Ix, 0.3 Ix plus 0.3 Ix, 0.6 Ix plus 0.7 Ix, 0.7 into Ix. Now here 30 into 0.1, 3, 50 into 0.3, 15 plus 3, 18, 18 plus 7, 25. So that means minus 25. So from this we get 28 by 0.7, which is 40 ampere. Ix equal to, we got what? 40 ampere. And after that what? Now you redistribute the current based on what? Ix value. Have a look, sir. I am drawing as it is this. We don't know what is V2, we don't know what is V1. But I know this current is what? 30, and this is what? 20, and what? 20. Look here, sir, we got finally Ix is what? 40 ampere. And if that is the case, 40 minus 30 is what here? 10 ampere. But this fellow is drawing 20. From here 10 is coming in. From here 10 should come. Yes, it will come because supply is there. No need to worry. That means current is coming to point B on both sides. From the both side current is coming to what? Point B. Nothing but this is what? The minimum voltage point. Here the voltage is minimum. That is a conclusion. Okay. That means the answer for first question is what? The first question is asking identify the minimum voltage location, which is what? B location. Okay. Now let's see, sir. If this is 10, but what about this current? 30 amperes. Why? Here 20 ampere is going. Clear? Now let's see the voltage drop in every section. So this side plus and this side minus. Current entering terminal is plus. What is the resistance? 0.2. 40 into 0.2, this is what? 8 volts. Clear? Now here 10 into what? 0.1, which is what? 1 volt, plus minus 1 volt. And here direction will change. Why? The current got changed here, plus this side and minus this side. 10 into what? 0.3, that is what? 3 volts. Now here 30 into what? 0.1, that is again what? 3 volts. Now just check, sir. From here to here, the voltage drop is what? Something like this, plus minus how much? 6 volt. Now what about from here to here? The voltage drop is minus plus 8 plus 1, 9 volts. Now what is the maximum voltage drop? 9 volts. That means the distributor is designed based on what? 9 volts. The size is what? Uniform. But that size is selected based on 9 volts, not based on what? 6 volts. Careful. Okay. So 9 volts is the what? Maximum voltage drop. Okay. Maximum voltage drop, delta V max, I can write 9 volts. Now you just check, sir. Total voltage drop is what? 3 volts. He has already given in the problem. 9 minus 6, 3. Satisfied. Clear, sir? So, and third question what is asking is, what is V1 and V2 if the minimum voltage along the distributor is what? 230. That means V minimum is 230 now. That means here the voltage is 230. If that is the case, what is the voltage here? 230 plus 9, 239. So V1 is what? 239. And what about V2? Simple, sir. So here the voltage 230. That means from here to here how much is the voltage? 6 volt. So that means 230 plus 6, 236. Now if you have any doubt, sir, again you can check, sir, whether you done correct or not. V1 minus V2 should be 3. Check 239 minus 236. Again what? 3 volts. So it's correct. Now last one, power loss. See what is the power loss? Have a look, sir. 40 square into resistance, 40 square into 0.2 in the first section plus second section, 10 square into 0.1 third section. This current is what? 10 ampere. Now 10 ampere square into what? 0.3 plus 30 square into 0.1. So if I solve this, we get 450 watts. So that's about the total power loss. Now this is how we need to solve for the distributor which is fed at what? Both the sides. Any problem is given, this is the what method. First step is calculation of Ix, then redistribution of current, then identifying the minimum voltage location, then calculation of voltage drops, then identifying the maximum voltage drop, and finally what? Calculation of power loss. Now this is the procedure, sir. Now we will see distributor fed at one end with uniform loading. Till now we have seen what? Concentrated loading. What is the meaning of uniform loading? Throughout the length of the line, the current is what? Uniformly drawn by the consumers. Okay. For example, let's see. This is what the length of the distributor from A to B. I am assuming that length is what? L meters. L meters. Okay. Generally we will see in meter. Okay. Now how the current is drawn by the load? Everywhere there is a tapping. Clear, sir? The magnitude of the current tapping is what now? I. Here also I, here also I. Everywhere the current is what? Uniformly tapped. Correct or not? So that means the load is represented with what? Current drawn, right? So everywhere the current is drawn here, it's what? Uniformly drawn. Okay, where I is the current drawn by the consumer per unit run. Unit run means what? Generally we will take what? Meter. Okay, if the length of the line is very high, maybe you can take what? Per kilometer. But generally what? Length of the line is less, since it is a distribution system. That's why we will generally represent this as what? Ampere per meter, where that I means what? The current drawn by the load in what? Ampere per meter. That means per unit run. And what about the total resistance? The total resistance is, let's say, R. Clear? Now I can say small r. Small r indicates what? The resistance per unit run. Nothing wrong to say resistance per meter length. Okay? So that means I is the what? The units ampere per meter. The current drawn by the load per unit run. Okay? R is the units of what? Ohms per meter. Clear? Sir, the total length is what? L now? Supply is from here. Okay? Tell me how much is the current supplied by the source now? See, here high, here high. For example, if it is a 2 meter length, sir, length is what? 2 meter. 1 meter length, current drawn is I. And second meter length, the current drawn is I. That means how much is the current you are supplied here? 2I. Correct or not? So that is what uniform loading, because every meter length, the loading is what? I ampere. I ampere per meter, better to say I ampere, otherwise this I ampere, this is also I ampere, every 1 meter length. Total length is 2 meter now. That means here high. After 1 meter length from the sending source, current drawn is what? I. Again what? I here. That means how much is the current total supplied here? 2I. Okay. Similarly, what I am saying is, what is the total current coming from the source? That is what? I, which is equal to what? Small I into what? Length. What is the total resistance of this distributor? Is capital R, that is equal to what? Small r into what? L. So now this is in ampere, this is in what? Ohms. So these things are very important, sir. So small I is the current drawn by the load per unit run. That means per meter length. Every 1 meter length, there is a tapping of current, which is what? I ampere. Okay, every 1 meter length there is a tapping of load current of what? 1 ampere, I ampere, small I ampere. Okay, so what is small r here? Every 1 meter length there is a resistance, that is what? Small r. Okay, now if I understand this, now I need to calculate what is the total voltage drop in the distributor, because I told you based on this total voltage drop only we are going to decide the what? Size of the distributor. So I am going to calculate the total voltage drop. In what case? Distributor fed at one end. Suppose if it is a distributor fed at both ends, then who will decide the size of the distributor? Maximum voltage drop. Okay. Now let's see how to calculate the total voltage drop. To calculate that, what I am assuming is, I am assuming a differential length dx at a distance x from the what? Source. This is what? The source. This length is what? X. Now what is this length? Delta x. The differential length dx, better to say, or delta x. Okay, the differential length dx I am taking. So if that is the case, delta x is very small, 0 approximately. Then after this, what is this length? Check, sir. L minus x. Correct or not? That means from here to here, what is the current supplied from here? I ampere, capital I ampere. Why? Everywhere small I is drawn. That means if you see from here, how much will be the total load after this? Capital I. Correct or not? Now tell me, what is the current coming through this section? That means, what is the current which is observed here? The total load in this section is nothing but what? The current flowing through what? This differential length. Okay? So, the current through that differential length delta x, current through delta x, because I want to calculate the voltage drop here, no? Means the current through this differential length is matters. Current through this is nothing but what? Whatever the current which is flowing here, whatever the current which is drawn from here. Okay, tell me how to calculate that. Very simple. Sir, this length is L minus x na? So L minus x into what? I is the what? Load after this point. Whatever the load after this point, or whatever the load drawn current after this point, that is coming through what? This section. Okay, that means this value is what? L minus x into I. What is the resistance of this section? R into what? Delta x. Now resistance multiplied with current will be the voltage drop. That means voltage drop within the differential length. What is the voltage drop within the differential length? Voltage drop within this differential length is what now? That is del V. Okay, that is equal to L minus x into I into what? R times the what? Del x or dx. If delta x tends to 0, nothing wrong to write what? Dx. Okay. Now tell me, I want to get the total voltage drop. Total voltage drop means what? You have to integrate from what? Here to here. For example, I want to get the voltage drop from here to here. Then what? You have to integrate from 0 to x. If you substitute x equal to L means that is what? The total voltage drop. Okay, that means voltage drop up to x meter length, or voltage drop within this first x meter length. What is that now? You have to integrate this with respect to what? X. Okay, the voltage drop within x meter length, that is what? You need to integrate delta V. Okay, not total voltage drop, delta Vx, that means up to what? X meter length. Okay, which is equal to what? Integration of this from where to where? Up to what? X. So what I get now? L minus x into I into R into what? Dx. If I integrate that, what I get, sir? Simple. L na here? L minus x na? So L into x minus x square by what? 2. Integration of L is what? L into x minus x square by what? 2 into what? I into what? R. Clear? So if I substitute x equal to L here, what I get? If I substitute x equal to L, so the total voltage drop we get. Total voltage drop means what? X equal to, you need to substitute L, that is what? Delta V. What is the delta V? L square here minus L square by 2 into what? I into R. So from this what I can write? L square minus L square by 2, simply I into R into L square by 2 is the total voltage drop from what? Point A to what? Point B. Clear? Now that's what the total voltage drop formula for what? Uniformly loaded distributor fed variant. The next important thing is total power loss. Very simple, sir. What is the power loss in this differential length? That is what? DPL. The power loss in the differential length is what? DPL. How to calculate that? Simple. Current square into what? R. So what I get now? L minus x into what? I whole square into what? R times the what? Dx. So total power loss means what? You need to integrate from what? 0 to L. Okay, total power loss means what? From 0 to L you have to integrate. So then what I get? So L minus x into I. L minus x whole square into what? I square into what? R into dx. So let's see, sir, what I get now. L square into what? X. Okay, plus x square integration is what? X cube by 3, right? Plus 2lx integration is what? 2l into what? X square by what? 2. Okay, we get what here? Minus, right? A minus b whole square formula. Okay, so L square x plus x cube by 3 minus 2l into what? X square by 2. This times what? Small I square into what? R. Okay, you substitute limits here 0 to L. You need to substitute x equal to L. That means what I get here? L cube plus L cube by 3 minus 2 to get cancelled. Again what I get now? L cube. Why? 2 to get cancelled. We get what here? L cube. So that's it. And times what? I square R. So if I solve this, we get the total power loss is I square R into L cube by what? 3. Clear? That's what? The total power loss in the distributor. So what is that? I square, small I square R into L cube by 3. So we done for total voltage drop and what? Total power loss. But if you write in terms of capital I and capital R, what I get, sir? The total voltage drop, what you got? IR into L square, na? I into L, R into L I can write. So that what I get now? Capital I into capital R by 2. So the point is here, suppose if it is a concentrated loading and the loading is finally connected here, then what is the voltage drop now? I into R. Correct or not? Because the total resistance is R, the current drawn is what here? I. The total voltage drop is what? I into R. That means if the instead of what? Uniformly loaded, concentrated loading, where the concentrated loading here? Then what is the total voltage drop? I into R. That's what the meaning. So, but if it is a uniformly loaded case now, then the voltage drop become what? Off. That is the idea. Clear? Now, what is the total power loss we get here? Sir, here I can write L square. That means IL whole square into R into L. That means what I can write now? Capital I square R in by 3. Again I am saying, capital I square R means what? If the load is at what? The B side and it is drawing what? A current of I ampere. That means it is what? Concentrated loading. For concentrated loading, the power loss is what now? I square into R. But if it is a distributed loading, uniformly distributed loading, the power loss is what now? I square R by 3. That's what we need to understand. So that's about what? The distributor fed at one end with what? Uniformly loaded. Now we will see distributor fed at both ends. Suppose if the distributor is fed at both ends with uniformly loaded, then there are two things you need to understand here. Number one is what here? The voltage at this point, let's say VA and VB. Suppose if VA equal to VB and it is uniformly loaded, means exactly at the middle of the line or middle of the distributor, we get the minimum voltage location. Correct or not? So, exactly at the middle, we get what? Minimum voltage location. Suppose, if this is our unequal voltages, that means VA is not equal to VB, then what happens? This point will be shifted from what? Middle of the line. Okay, that means the minimum voltage will not happen exactly at what? Middle of the distributor. It may be towards this, it may be towards this. When it will be shifted this side, if VA greater than what? VB. When it will be shifted this side, if VB greater than what? VA. But whatever it may be, we need to identify what is the minimum voltage location. Anyway, we will solve with what? Equal voltages at both ends and unequal voltages at both ends. Okay. Now, the first case is what? Equal voltages at both ends. equal voltages at both ends. If that is the case, it's very simple to solve. Exactly at the middle we get what? The minimum voltage. Now this is where we get minimum voltage. So that means here the current is in this direction, here the current is what? In this direction. Correct or not? Up to the minimum voltage location, the current is what? In this direction. Tell me what is the length here? L by 2. What is the length here? L by 2. Correct or not? The current is coming here, the current is what? Coming here. Okay. So that means what is the current supplied by source here? L by 2 times what? I. What is the current supplied by this source here? L by 2 times I. Again I am saying, sir, the VA and VB is there na? VA equal to what? VB. If that is the case, where is the minimum voltage location? The minimum voltage location is what? Minimum voltage at what? At L by 2 from what? Point A or source A, or what? Source B. Both are same. L by 2 length from what? Source A. Sir, if that is the case, what is the voltage drop? I told you voltage drop means what? Maximum voltage drop, na? Not total voltage. Total voltage drop is 0. VA minus VB is 0 because VA equal to VB. But I told you distributor is designed based on some voltage drop. What is the voltage drop? This voltage drop or this voltage drop. Both are equal. Correct or not? Either of this or this voltage drop, you can distributor is what? Designed. So that's why we need to calculate what is the voltage drop from here to here. Clear? Voltage drop from here to here. I am assuming what? Delta V. So how to calculate this delta V? Very simple, sir. Sir, if you think about distributor fed at what? One end case, the total length is L, the total voltage drop, actually current is what? Everywhere in this direction. The total voltage drop what we got? Just now we calculated. I into R into L square by what? 2. So same thing here, but what is the difference is, this is what? L by 2 length. Current is what? Coming in what? One direction only here. This is what? L by 2 length. Current is coming in what? This direction here. That means in this formula, if you substitute L equal to L by 2, that's enough. We will get the what? Voltage drop up to what? Minimum voltage point. Delta V up to what? Minimum voltage point is equal to what? I into R into what is L now? Just L by 2. That's it. Simple story. L by 2 whole square by what? 2. What I get now? I R L square by what? 8. Otherwise simply IR by 8. Now let's see what is the voltage drop. Become what? 8 times. When you compare with what? Distributor fed at one end, and loaded at what? At the receiving end. So that will be what now? IR by 8. That means the voltage drop is decreased by what? 8 times. So you can take the advantages of what? Reducing the conductor size. Correct or not? I told you voltage drop is the deciding factor for deciding the size of the distributor. So voltage drop become what? 1 by 8 times of what? The original voltage drop when compared with what? So distributor fed at one end and what? Concentric loading. Okay. Anyway, so this is the formula for what? The distributor fed at both ends with what? Equal voltages at both ends. Okay. Clear? And now what is the total power loss? What is the total power loss? How to calculate, sir? Again, sir, simple. Total power loss is power loss in this section plus power loss in this section. Okay. Power loss in this section plus power loss in this section. How to calculate that? Sir, same thing. So power loss what I got earlier? I square R into L cube. You substitute L is what now? L by 2. So what I can write? So I square R into what? L by 2 whole cube divide with what? 3 plus this is what? One section power loss. Other section power loss? I square R L by 2 whole cube divide with what? 3. So what I get here now? I square R into L cube divide with what? 12. Clear? So finally what I get now? Capital I square R by what? 12. That means if we compare with concentric loading and what? Fed at one end. So this will be what? 12 times reduced. Correct or not? So I square R divided with what? 12 we get. So this is what? Equal voltages at both ends. Suppose if it is unequal voltages, then how to solve, sir? Unequal voltages. What is the meaning, sir? VA is not equal to what? VB. Okay. So if that is the case, what our assumption is, the minimum voltage location is at what? X distance from what? Source A. The minimum voltage location is X distance from what? Source A. That means what is this now? L minus X. Okay. X distance from what? Source A. That means this is L minus X. Tell me how to write V minimum. V minimum equal to VA minus voltage drop in this section. How to calculate the voltage drop in this section? Okay. So in this section current is only in this direction, right? That means you assume that the length of the distributor, it is a distributor fed at one end. If you forget about this, this is a distributor fed at one end, having a length equal to what now? X meters. So what is the formula? I R L square. L square means what? X square by what? 2. Then what is V minimum? We can also write from this VB minus IR. What is this length? L minus X whole square by what? 2. These two equations are what? You can equate 1 equal to what? 2 and solve for what? X. After solving for X, based on the X, we need to calculate what is the delta V. Delta V means what? Maximum voltage drop. After calculating the voltage drop, then you can calculate what? Total power loss. What is the total power loss? Simple. Total power loss equal to what? So what is the power loss in this section? So same, sir. I square R, L is nothing but what? X. X cube by 3 plus I square R, X is nothing but what? L minus X whole cube by what? 3. Clear? By adding this, you will get what? Total power loss. The thing is, you need to calculate X. Once I know the X, the remaining things are what? Very simple. Clear? Now that's about the distributor fed at both the ends. With equal voltages at both ends, unequal voltages at both the end. Now see this question. A uniformly distributed load on a distributor of length 500 meters. That means the length of the distributor is given 500 meter. This length is given as 500 meter. Fine. Clear? And the loading is what? I, that is what? 1 ampere per meter. And the loop resistance is given 4 into 10 power minus 5 ohms per meter. Okay? Sir, idea of the loop resistance is actually a distributor means it is a DC distributor or AC distributor. Generally, we have 2 wires. Okay? So DC means 2 wire. Single phase means what? 2 wire. Sir, when you are calculating the voltage drop, you require what? Loop resistance. Otherwise, let's have a look. This is what the length of the distributor. Each wire resistance is R. Then the current flowing here is I. Then this current is going through the load and take the return path like this. Correct or not? What is the voltage drop from here to here? IR. Then what is the voltage drop here to here? IR. What is the voltage drop total? IR plus IR, that is a total voltage drop. That means 2 into what? IR. Otherwise, I times the what? 2R. Now this 2R is nothing but the loop resistance, total resistance. Single wire resistance is given, for example, in the problem. Sir, you have to multiply with what? 2. Because we need what? Loop resistance. Correct or not? Clear? Because the current is going here and what? Take the path through the what? Load, and finally what? Takes the return path. That's why total voltage drop is what? Considered. Okay? In the go wire and what? Return wire. Careful about this. Okay? If you are not taken 2 multiplication, you end up with wrong answer. But here you don't need to take the 2 multiplication. Why? By default is given in the problem loop resistance. Okay? Right. Anyway, so loop resistance is given. Directly you multiply the current with what? Loop resistance, that will give directly voltage drop. Okay. Now, coming to the first question. If distributor is fed at one end, the distributor is what? Fed at one end. Okay. At 220 volts, find the voltage drop at a distance of 400 meter and what? Total voltage drop. Okay. Is asking the voltage drop at a distance of 400 meter and total voltage drop. So, if I want to calculate that, have a look, sir. See, maybe this is what the length x, that is equal to what, 400 meter. Now how the current is flowing here in this direction, correct or not? Here also what, in this direction. Okay, now let's see how to calculate the voltage drop at a distance x from the sending end, if it is what, fed at one end, or x from the source point. Sir, we can use this formula, delta V at a distance x. We derived this, what, I into R into x into L minus x square by 2. Sir, maybe the people may have a confusion here. Why can't apply this I into R into x square by 2 just like we did for what, distributor fed at both end case? I cannot apply. Why? Because in case of both end case, what my point is, here the current is in this direction. That's it. After that the current is in this direction. You can think that up to here what, distributor fed at one end, up to from here is what, distributor fed at what, one end. But here the things are not like that. Shall I say up to here distributor fed at one end? No. Up to here distributor fed at one end. Why? Current is flowing here up from this direction. Later also what, going in this direction. But here the story is different. The current is what, coming here. That's it, ended. Then current is coming here and ended here. So that's why, sir, I cannot apply this formula, IR into x square by 2 formula, you cannot apply. Only you have to use this formula. Okay, now have a look, sir. Coming to the point, he is asking the voltage drop at a distance x from the sending end point or what, source point. So how to calculate that? I is what, 1, and what is the resistance, loop resistance per unit length? 4 into 10 power minus 5 into x, 400. This is in per meter. That's why x and L should be substituted in what, per meter. Okay, 400 into 500 minus 400 square by 2. If I solve this, I get 4.8 volts. Now that is what, delta Vx. That means the voltage drop up to what, x meter length from what, source location. Clear, sir? Now one more, here total voltage drop is asking. Total voltage drop means what? You can apply this formula, IR into what, L square by 2, nothing wrong. So what is this now? I is 1, R 4 into 10 power minus 5, L 500 square by what, 2. So if I solve this, we get 5 volts. That is the total voltage drop. So that's about the first question. Clear? Now we will see the second question. Now coming to the second question, if distributor is fed at both ends with equal voltage of 220 volts, then calculate the maximum voltage drop. Sir, fed at both ends with equal voltages here and here. That means minimum voltage is what? Exactly at middle. So that means what is this, sir? L by 2. What is this? L by 2. So maximum voltage drop means, I told you, sir, the voltage drop here and here equal. So maximum voltage also what? Same from here to here and here to here. That means, so you need to calculate the voltage drop maximum. That is nothing but what? I into R into L is nothing but what? L by 2 whole square by what? 2. So that means IR L square by what? 8. So let's substitute I, that is what? 1 ampere, 4 into 10 power minus 5. L is nothing but what? 500 square divided with what? 8. So if I solve this, we get 1.25 volts. Now that is the delta V max. This is for what? Fed at both ends with equal voltages. Clear? Now coming to the third question, the distributor is fed at both ends but unequal voltage of what? 222 volts and what? 220 volts. Okay. So what is the meaning here? VA is what? 222 volts. VA is 222 volts. Clear? And VB is what? 220 volts. Sir, if 220 means exactly middle. 222 means what? It will move this side. That means this is what? The minimum voltage location. Okay, we need to find out that, which is x distance from 222 volts is asking. Okay, now what is this now? Indirectly L minus x. Okay, let's see what is the formula, sir. V minimum equal to what? VA minus IR x square by what? 2. And we can also write V minimum equal to, from the source B, VB minus IR L minus x whole square by what? 2. So these two are equal. If I substitute 222 minus I, that is 1, okay, 4 into 10 power minus 5 divided with what? 2 into what here? X square, that is equal to 220 minus I 1 4 into 10 power minus 5 divided with 2 into L minus x whole square. Clear? Sir, we will substitute at the end. First we will solve this. Sir, 222 you bring here, 220 you bring here, that means we get 2 here. So 4 into 10 power minus 5 by 2 is common, that means what I get? 2 into 10 power minus 5 multiplied with here x square minus here what? L minus x whole square means what? L square x square plus 2lx. So x square get cancelled. Now I will substitute what is L. 2 equal to 2 into 10 power minus 5 into L square. L square means what? Sorry, minus we get, minus L square means okay, minus 500 square. X square is get cancelled, plus 2 into 500 into what? X. Let's take this 2 into 10 power minus 5 inside. What I get now? 500 square na 25 into 10 power 4, otherwise 2.5 into 10 power 5. Okay, so that what I get now here? 5. Correct or not? So 25 into 10 power 4, otherwise 2.5 into 10 power 5 into 2, 5. 10 power 5 minus 10 power 5. Okay, but this is minus 5 and this side is what? 2. Plus, now let's see here 2 into 500, that is 1000. 1000 into 2 into 10 power minus 5, that is what? 0.02 x. So from this, x equal to 7 by 0.02, which is what? 350 meters. That means, so minimum voltage is at what? 350 meters. Clear? That is the one question. The minimum voltage location from 220 volts end, that is what? 350 meters. And what? Calculate the current supplied from both the ends. That means, what is the current supplied here and what is the current supplied here? So that means, the current supplied from A side is what? IA. Let's see, that is equal to what? 350 into what? 350 meters. 1 ampere per meter na? So that's why 1 ampere per meter you get what? 350 amperes. Now current supplied from B side is what? IB, that is what? So if this is 350, this is what? 150, because total length is what? 500. So 150 into what? 1 ampere per meter, which is what? 150 amperes. So that is the answer for what? Third question. The x is at 350 meters. Current supplied is what? From A, 350 amperes, and current supplied from B, that is what? 150 amperes. So with this we finished distribution system and also our PS1 course, which is transmission and distribution, and again we will meet in PS2, that is analysis part, and after the analysis we will see the protection part and then LFC. Protection and LFC together, that is what our PS3. PS2 deals with power system analysis. We will meet again in power system analysis course, okay, but practice all the questions which are given in handouts. So all those questions are very important. Now if you are able to practice whatever the questions we are putting in handouts and whatever the questions we discussed in this video lectures and quiz questions and previous gate questions, that is more than sufficient for what? Gate exam. See, whatever the effort we are really putting to give the best lectures to you, if you put the same effort, 100% you will get top 10 rank. All the best.